Hello, all. Hope you're doing well. So we are continuing the second part of this polyfunctional organic compounds, and we are going to take some examples of different structures just to understand this entire concept better. Okay, too many functional groups in one structure. So okay, done with adding the hydrogens. So now in this first we need to figure it out, which is our principal functional group. So not principal functional group, like the functional group which is having higher priority, the main one, the main, you can say, hero in this organic compound. So it's going to be our carboxylic acid. This is going to be our carboxylic acid. So it's definitely going to end with oic acid. Then we have alcohol, and alcohol we know the prefix hydroxy, and then we have CONH2. This is acetamide. Now, if you go back to my previous video, I've told you, I've given you one table where acetamide amides basically have this prefix. The prefix is carbomyl, right? So, how we are going to name this entire structure? So, since this group is going to be acting as a prefix, alcohol is going to act as a prefix. So, what is going to be our main parent chain? So, we have just one carboxylic acid. That means we can add this carbon of the carboxylic acid in the main parent chain. We can do that. So, let's number it as 1. This is going to be 2, this is going to be 3. Now what we need to understand over here, we are not going to number this carbon as 4, because this is acting as a substituent for us, because it's a polyfunctional organic compound. This will come under prefix carbomoyl, or you can pronounce carbamoyl. Anyways, coming to the naming part now. So ABC, C comes first, so this will be our carbamoyl, and this is our hydroxy, and then we have over here on the second carbon, this is methyl, correct? So we have to follow alphabetical order. So we are going to start from 3 carbamoyl, 3 hydroxy, then 2 methyl, propanoic acid, right? Okay, what will you do if I add a double bond over here? What will you do in that case? Then it will become prop 2 enoic acid. Okay, if I add a double bond over here, prop 2 enoic acid, because double bond will be at the second carbon. So enoic acid, that means 2 enoic acid means that's basically one position. So I didn't write 1 over here. It's understandable, it's on the 1 carbon. Fine. So then we go to the next one. Let's introduce a double bond over here. Okay, done. So now we have to introduce hydrogens. This is covalency is done. Okay, let's figure it out. What do we have in this? We have an aldehyde. This is an aldehyde, CHO. We have hydroxy, that's alcohol. And then we have 2 aldehydes. If you can see, this is 2 aldehydes, and then we have carboxylic acid over here, and then you can see the double bond. Okay, at least first step is to figure it out, what do we have in the organic compound over here. If you have done that, at least 50% of the job is done, 50% of the stress is gone. Okay, now what do we have to do? We have two aldehydes over here. We have one carboxylic acid that keeps this. That's going to clear this thing for sure. That carboxylic acid is a main functional group. It's going to have highest priority, right? So we are going to keep it in the suffix for sure. So we are going to start the numbering from this carbon. We'll talk about the rest. So one carbon. This is going to be second. We have to keep the double bond in the chain, at least in this case. So 3, and then we even have to number this carbon as 4. Why? Because your alcoholic group is attached. And then we are not going to number these aldehyde group because they are attached to the main parent chain, right? They are acting as a substituent. They are going to come in the prefix over here because it's a polyfunctional organic compound, right? So we will call them as aldehydes. Aldehydes can be called as formyl or it can be called as oxo. It's up to you. So let's try to name this organic compound now. So it's going to be, so I'm going to use formyl in this case. So it's at second carbon aldehyde group is there, this one. And at fourth carbon aldehyde is there. So 2, 4 diformyl, 4 hydroxy. So alphabetical order F and H. Then you have methyl also, 3 methyl, and then we will write but 2-ene 1 oic acid, or you can just write enoic acid, that is understandable, right? This I have told you a number of times if you have seen my previous videos. Between 2 and 3, take the lower position between the double bond. Next, let's take this structure. You can see this is COCl. This is alkanol chloride we are talking about. Let's add amine. Here. Now in this, what do we have? We have this COCl. This is one group, right? We have NH2. We have CH3. You put the hydrogens. And then you can see over here, this is our ketone. This I'm talking about. This is our ketone. C double bond O. And this CONH2, this is amide. So at least we have figured that out. All these things, right? So now what we need to do over here? Let's try to rewind what is going to come in the prefix. So over here, if you see the priority, amine is always, you can say, is having low priority, right? Amines are basically having low priority. Then your acyl halides are basically these COCl, right? And amides are basically even low. So if you compare, ketones are basically at the top, right? Okay, so now if you go back to the priority list, you might have seen that your amine is definitely going to come in the prefix. Then you have this the CONH2 group, that is CONH2 is basically having high priority compared to COCl, right? And keto is basically having less priority. So if you see the basically, if you see the priority list, you'll be able to understand. So I'll just write it for your convenience over here so that it is understandable. I'm going to write it again. COH is having carboxylic acid. Okay, we don't have carboxylic acid over here, so I'll write it from here. COCl is having high priority. Then comes CONH2. Then comes ketone, C double bond O. Right, so amine is definitely going to come in your prefix. Methyl is going to come in the prefix. So now how we are going to name this entire compound? So if you can see, the one which is having highest priority is this structure. So it's going to be this carbon, COCl, acid chloride also we call it. So we'll start the numbering from here, 2, this is 3, this is 4, and then we can go to this carbon. So this was not methyl, it looks like methyl, I think I was wrong. So this is fifth. So now if you see according to the priority, CONH2, right? CONH2 is having low priority. That means this is going to come in the prefix, and even keto is going to come in the prefix, right? Sometimes it becomes a lot complicated. It makes, anyway, so you have to, cross check multiple times, because uh, some things can be wrong sometimes, a slight mistake. You have to keep so many things in your mind when you're naming organic compounds, and anybody can make mistake. Okay, so this is done. So now coming to the naming part. So from where we are going to start? We are going to start from A, amino, which is at 2 position. So it's going to be 2 amino. Then we have at 4 CONH2, prefix is amide, not amide, sorry, carbamoyl. 4 carbamoyl. Then we have 3 position. So for ketones, we have a prefix oxo. We can write oxo. So I'll write, in some cases we can write keto also. That is also okay. Then we have 5 carbon in the main parent chain. So we are going to write pentanoyl chloride, because this is our main function group having highest priority. So alkanoil or chloride, or you can just say oil halide. So it's alkanoil halide, you can say that. Okay, then we go to the next question. Let's add OH group, NH2. Let's add NO2, Br also. We can add chlorine. We can add a double bond also, CONH2, and then carboxylic acid. See, I've added so many we have added in this. So now coming to the main thing, see what you have to look at carboxylic acid. This has to come into the main parent chain. So this has to be uh, second carbon, third carbon, fourth, fifth, sixth. Now can you see we have CONH2? It's not going to be numbered. Then we have aldehyde also. So it's not going to be like numbered, because it's acting as a prefix. It's acting as a substituent, so it will be used in the prefix, right? Now coming to the naming part, you have to keep so many things in mind, and the best, not best, you can say the most important part is the alphabetical order that you have to cover up over here. So we can start from here. NH2, amino, A. The next will be what? B, 4 bromo. Then we can actually take C, carbamoyl. So at 2, we have carbamoyl. Then you go to another C, that is chloro. So you can actually see Ca is going to be there alphabetically coming first. So 3 chloro CH. You can see like that also. If we have this kind of problem, then we see the second alphabet in the name also. Okay, so 3 chloro. Then we have our this is done. Okay, nitro will come late, because we still have to write hydroxy, right? But aldehyde is there. So aldehydes, we can use formyl. This is going to be at 6 formyl. Then after that we are going to our hydroxy, 5 hydroxy. Then at 4 position we have nitro, and hex, 6 carbon are there, hex. Then you have double bond at 2. If you can see this part, 2 and 3, 2 enoic acid. Quite a lengthy name, right? So hexene you can write 1 oic acid, but otherwise if you write enoic acid, that is also understandable. Now let's take a break from these. We can do some other type of questions. Let's talk about acid chlorides. Or acid halides. So RCOCl. You can open this. This is also having a carbonyl group. So the suffix that we use is oil chloride. So a simple example, if we take COCl, so the name of the structure will be 2-methyl propanol chloride. That's a simple example we have taken. We can take another example where you have two groups like this. Then you know that you have to take this as a main parent chain, right? So for 2 it's okay, but if you have 3, then again we are going to use the same concept that we use for carboxylic acid, having 3 COH groups. So it was tricarboxylic acid, right? So in this example, 1, 2 and 3. So on 2 you have methyl and ethyl also. So this will be alphabetical order. E will come first, 2 ethyl, 2 methyl, propane, all single bond, 1 comma 3, dioyl chloride. Now if you have something like this, so sometimes they try to open the structure and try to make you confused, like okay, what is this? Some people will say, okay, this is ketone and this is chloro halogen. No, if they are attached to the same carbon, they are acid chloride. So now can you see we have 3 of these? 1, we have 2, and we have 3. No, not 3, oh sorry, we have 4. And then you can put the hydrogens. So what to do in this kind of situation where you have 4? So we will not number those carbons of COCl. We will take a parent chain, this parent chain, 1, 2 and 3. Now again, why we are starting from this carbon and not this carbon? Because if you see, this carbon is more substituted, having two COCl groups, whereas this carbon is having only one COCl group. So why not to start with the more substituted carbon of this chain? So this is our main parent chain. 1, 2 and 3. 3 carbon is over here. So now we don't have any prefix over here, any other prefix. So we'll start from the word root, propane, 1, comma 1, comma 2, comma 3. So we are going to write tetra carbonyl chloride. That's a name, right? So in most of the cases, it's always going to be this situation. When you have 2, you take the carbons in the main parent chain of the functional group. But if you have more than 2, if you have 3, then you just take them as a, don't count those carbons in the main parent chain, take them as a substitute. So one more example we can take over here for cyanide. C triple bond N attached to any alkyl group. So if we have a structure something like this, So let's see the structure. You have too many cyanide, and the suffix for cyanide that we have is nitrile. I've told you in that table in the previous video. So, so how we are going to proceed with this? So you can see there are too many, right? There are four cyanide over here. One is this one, second, then third. No, there are three only. Yeah, three only. So let's put the hydrogens. Okay. So now again you have to follow the same pattern. You are not going to number the carbons which are triply bonded to nitrogen. The cyano groups, basically nitrile groups, you are not going to number. So from where should we start the numbering? So we can start from either this carbon, like I'm talking about this carbon, 1, 2, 3, and 4. Or you can go from here, from bottom, 1, 2, 3, and 4. So this is not numbered, this is not numbered, and then you have this as ethyl, and you have methyl, and this again group. So now how to name this one? So alphabetical order, ethyl will come first. So at 3, ethyl is there, then 2 methyl, butane, all single bonds are there, 1 comma, we have 1 comma 2 comma 4, tri carbonitrile. Right, so there are multiple examples that you can go through. Even for aldehyde you are going to do the same thing, so that if you have 3 aldehyde groups, that will become tricarbaldehyde, right? So when it comes to ketones we always try to keep in the main parent chain. So trione, it can be dione. So we don't work like that when it comes to ketone, because ketone is never going to come in the terminals, right? It's always going to come in the middle. So you have to take it in the main parent chain, right? So we can do one question for ketones, and then we can end this video, and I'll be taking up amines in a separate video later on. So if you see this, you have ketones, right? 3 keto groups are there, 1, 2, and 3. So how to name it? So you will take the long chain. So the chain which I can see over here, 1, 2, 3, 4, 5, 6. This can be our chain. And this is going to be a branch inside branch. So let's put the hydrogens. So 1, 2, 3, 4, 5, and 6. So we will start from this alkyl group. We just have 1, 4, bracket open. So it will be 1 and 2. So 1 methyl, ethyl. This I've covered in the previous videos also. Hexane. 6 carbons are there. 2, comma 3, comma 5. Trio. Right? So I hope this video was helpful. We are going to discuss many more questions in the future. So please keep on watching these kind of videos and keep on sharing and subscribe my channel and share with your friends, whoever is in need. And thank you so much for listening to this video.